Hi, everyone. Welcome to another episode of Solidity Fridays. We have an exciting episode today, joined by DcBuilder and Yuval from Web3 Sanctuary. So you guys, do you want to do an quick intro? With Yuval, you start. You can kick it off.
Yeah, of course. We'll leave the best for last. Hey, everyone. Super great to join you on the stream. I've been a long-time watcher and appreciator of Solidity Fridays. I am a Solidity engineer by background, and I currently head growth and partnerships with Web3 Sanctuary, which is a next-gen edtech platform that's focusing on onboarding the new wave of software engineers into Web3. Over to you, DC. We're super excited to have you.
Hello. I go by DcBuilder, or DC for short. I am a research engineer on the protocol team at Worldcoin, or more specifically at Tools for Humanity, which is the primary developer of Worldcoin. And today we'll be going over the World ID contracts and some other related code bases to them.
Yeah. Amazing. Yeah. So if you guys have any questions, just pop them through and we can address them live with DC. Alrighty, and I'll share your screen and I'll let you kick it off.
So I thought I recently made some diagrams, just very light diagrams that go a little bit over what World ID is in a nutshell, or at least what the general concept of the protocol is, and then just show the diagrams and actually the code base from an actual implementation perspective. And feel free to step in if you have any questions.
Amazing.
So World ID is a privacy-preserving proof of personhood protocol. So proof of personhood is sort of this concept in which if you want to build an application where you want to essentially make sure that the user doing an action is unique and that the person doing that action is not done that action before, well, you need to have some notion of personhood, right? If you've seen things like voting apps, apps within DeFi and DAOs, they're this where you can only vote tokens you have. One type schemes, and there's no proper solution. Maybe it's like Gitcoin Passport or some other solutions. So essentially, World ID is this protocol that allows you to prove personhood in a digital context. And in this context, specifically within a blockchain. So World ID, right? The way that we prove personhood within World ID is that a user essentially goes to an orb. In this case, an orb is a hardware device. Maybe I can pull out the white paper really quickly, the Worldcoin white paper, and one of the sections which has an image, so you guys have more of a. So sorry, my internet is kind of slow. There we go. The orb. There we go. So the hardware device, which when it's assembled, it looks a little bit more like, if I find the assembled image, if it's here or not. Anyway, I'll just leave it into the assembled image. So it's a hardware device that essentially what it does is two things. One, what it does is to determine whether a person is real. And for that, it has a bunch of sensors and lenses that are able to essentially detect whether a person is wearing contact lenses, whether a person is wearing glasses, that they have a continuous heat map, and so on and so forth. I really recommend you to go over the white paper if you have more questions. So it first determines that person is real, and once it determines that it's real, it takes a high resolution image of both of the person's irises, and it computes a representation of those irises called an iris code, which looks something like this at the bottom, right? So it takes an image of an iris and it computes this iris code thing. And this iris code is essentially a way that you can compare one iris code to one and determine whether a person is unique. This is the only thing that leaves the orb. It's pseudonymous, right? Like there's no way to infer which person it was just from an iris code. Unless, yeah, it's like I really recommend going through this. I'm just trying to go over it quickly. Right, so this iris code, once a person generates a unique iris code and they get registered, you essentially have this protocol called Semaphore, which we are using under the hood. So Semaphore is a protocol that was built by the Privacy Scaling Explorations group at the Ethereum Foundation. And what it does is it allows you to essentially prove inclusion inside of a group, right? So if I am a person that has essentially been verified to be a unique person via the orb, then I get added to this Merkle tree, or essentially just like a public database on Ethereum, where I'm able to prove inclusion using this Semaphore protocol. The cool thing about Semaphore is that it uses zero knowledge proofs to hide the person that it's proving to be of this Merkle tree, right? So I'm able to do a proof without revealing that which member I am. And this member, like the thing that is inserted in the Merkle tree, is just a public key, right? So it's not like you're inserting any biometrics or anything. So that's the cool part of Semaphore. And at Worldcoin, we use Semaphore to essentially prove that a person is unique, right? So the orb proves the person is unique, inserts a Semaphore public key into the set of registered users, which I can go over into the code a bit. And essentially, once the user is inside of this Merkle tree, a user can call a verify proof, essentially function method on this contract to prove that they're part of this Merkle tree and that they haven't done an action before. So World ID, this has this concept of actions. So let me just really quickly find the docs. I'm gonna have a cool, yeah, there we go, awesome. So World ID has this notion of an action. The way that you generate an action is that you generate an app ID for whatever app you're integrating. This can be a smart contract or an off-chain application. You generate an app ID and an action ID, and this action is represented as the hash of an app ID concatenated with the action ID. And so each person submits this so-called nullifier, which is this hash of the action, to the smart contract alongside with the conclusion that they're a unique user, and they're able to prove that, okay, here I'm a unique user and I've never done this action before. So if you want to build, for example, a voting protocol, right, you'd create this essentially this system in which you generate a smart contract for voting on chain, and you gatekeep function via the World ID verify proof, and integration, then the user needs to generate a World ID proof using their app, World app. So registered, they download an app, they go to an orb and verify World ID, and each user sort of self-custodies their private public key pair for Semaphore on their phone, and then they're able to generate a proof locally on device, a zero knowledge proof in this case, that they're part of the set of registered users and that they've not done an action before. And then they send this proof via World ID, the SDK, the ID kit SDK. They send it to the smart contract, and the smart contract then verifies, okay, this person is unique and they have not done an action before. So that's sort of like the high level overview of World ID. It's a lot to take in at first, so I'm really curious if Yuval or Rebecca have any questions, just to get started for now.
Yeah, absolutely. Just walking back a couple of steps to where you were a little earlier, for our understanding, do you take the iris hash, so the hash of all the iris data embedding, and use that to create an account for somebody without actually exposing that iris data to the blockchain?
Yeah. So that's a good question. So there's this essentially this normalized image of an iris, and it gets covered by iris code thing. This iris code, you can think of it as a vector representation that you can then do Hamming distance across. Hamming distance is sort of like a mathematical operation that you can do to compare these iris codes across each other. And so you essentially compare these iris codes on a backend, like a traditional server backend. So the only thing that leaves the orb to the backend is this iris code. The iris code is not biometric information. It's just a representation of the randomness encoded inside of the human iris. Right? So this image gets deleted within the orb, never leaves the orb. And the only thing that leaves is the iris code. And then once you have this iris code on the backend, if the gets checked using this Hamming distance concept against all the other ones, determine that this given iris code is unique, each user will download the app. They generate a semaphore public-private key pair using a cryptographic library, the semaphore RS library, actually one that we wrote. It's a binding protocol written in Rust. And once they generate this public key and they're verified, well, then is able to insert this public key into the contract. So it's sort of like an operation in which the only way you insert a public key verification is through a permission back. We're working on ways where you can like further decentralize these processes. However, it's like pretty big technical challenge to coordinate all these things together. But yeah, no biometric information ever hits the chain. Not even this iris code. The only thing that hits the chain is a semaphore public key, which you can use as a traditional like cryptographic public key, which is pseudonymous, right? It's just one user has a public key on their phone, and they have the corresponding key, which they can generate proofs.
Amazing. That's super insightful. Thank you. Perhaps before we dive into the contracts directly, maybe you could talk for our listeners a little about the high-level concepts in terms of how you were thinking about identification versus verification.
Mm-hmm.
I know that's something that was touched upon in the Worldcoin white paper, I think that it might be super interesting.
Yeah, I think, well, it depends how you define both of those. Identification is usually a concept where you're mapping some information to a real-life human being, as opposed to verification, where you're mapping, essentially you're verifying that a given user is unique, right? So identification is you're identifying a given individual, which World ID is not doing. What World ID is doing is that a person essentially has some entropy encoded inside of the person's iris, and based on the randomness that it's encoded over there, you're able to create a representation of that randomness and associate a public key to that randomness. And as long as that randomness is unique, right, has not been inserted more than once into the backend, then the public key can be inserted into the Merkle tree. And so this once you have this public key, then everything from there is completely pseudonymous, right? Like able to have a semaphore public key as a user on my phone, able to create a zero knowledge proof that, hey, I have a private key corresponding to this public key, without revealing which public key it is, because the proof happens using essentially it's using zero knowledge cryptography. I can also go a little bit deeper into what a zero knowledge proof is if you want me to. However, there's other materials also for that I can refer to. There's like varying levels of depth we can go into here. It's a lot to cover, so I don't know. It depends like what you want me to talk about here.
Absolutely, thank you. Perhaps you could give like a 1 or 2 liner about what a ZK proof is for our listeners, and maybe like a common use case, and then tell us a little about how you think about zero knowledge cryptography in context of Worldcoin, how you've been approaching it. I know it's a big interest of yours.
Mm-hmm. All right. So zero knowledge proofs are essentially a way to that some computation happened correctly without revealing anything else of computation besides the statement that you're proving. So I can, for example, say that, hey, I know the solution to a Sudoku puzzle without me having to reveal that solution. The way that works is some really cool mathematics, some of which is based on elliptic curve cryptography in the case of SNARKs, or succinct non-interactive arguments of knowledge. Some of the other cryptographic constructions are based off of these constructions are called STARKs. And essentially what these proofs allow you to do is make statements about some computations without revealing some information you can keep. In this case, the computation we're proving is that I have a specific item, a specific leaf of a Merkle tree, and I can prove to a verifier that I have that's part of this tree without revealing to the verifier which leaf it is. And if you trust the assumption that the cryptography works well, right? If you treat it as a block box, then you can essentially create these really small proofs. And by small, I mean that they're to verify, like computationally. It's just checking points on an elliptic curve. And I, as a verifier, can have complete guarantees, complete assurances that this is indeed the case. So essentially, there's two main players inside of a ZK system. There's a prover and a verifier. It has access to all the private and public information, and the verifier has only access to the public information. Prover makes some statement about some computation. Verifier can verify this proof in an computationally easy way, so they can verify. Also, another thing to note is that the succinctness, what it means is that it's easier to verify a proof than to do the computation itself. And this property, for example, is used within zero-knowledge rollups. So rollups are these scalability solutions where you have this off-chain system, this off-chain blockchain, where you have some state transition, right? You have some state, let's say like the blockchain state from block height 100, and then you go from blockchain height 100 to 101 by submitting some transactions into a new block. What it does, the prover submits a zero-knowledge proof that all the transactions happen correctly according to some virtual machine specification, for example, EVM, like with ZK EVMs. The verifier can verify that this state transition happened correctly, and you can essentially update the state that is committed to L1. So it's like a way to scale, for example, or also a way to build privacy-preserving applications, right? Like I'm able to do a transaction using Zcash or Monero, where my balances are hidden and my transaction spends, like my UTM spends, are hidden. There's like lots of different use cases for ZK cryptography, and they're only like getting like wilder and wilder since the tooling is better and people are more assimilated with the technology, so they're creating really cool things with it.
That was definitely one of the more succinct explanations I think I've heard of zero-knowledge cryptography. So thank you for that. I would love if we could take a dive straight into the contracts, if that's good for you.
Awesome. Yeah, so I'll give a little bit of a walkthrough of how do you create a world ID flow. So currently we have a few moving pieces. We even get to essentially inserting a new leaf into the Merkle tree. So as world ID has a Merkle tree of verified users, in which case the Merkle tree goes for public keys. And so the orb backend is a service on the orb that essentially verifies the uniqueness of the code. Once an RS code authenticates a public key, I don't know if this is readable. Can you read this text?
Yeah, you can see it.
All clear.
All right. So once an orb authenticates a semaphore public key, well, it gets sent to the sign-up sequencer. The sign-up sequencer is a Rust service, a Rust server, essentially, that has some API endpoints over here. And let me just do insert identity. Right. So there's some API endpoints on this, and once the RS code is verified and the semaphore public key is authenticated, well, it gets sent to this sign-up sequencer into the insert identity API route. And what this does is it essentially calls it calls a method on the world ID contracts to insert a new identity in the tree. Before, in the previous versions of world ID, we used vanilla semaphore, for which each insertion was one single transaction. And this was inefficient because if you consider like gas fees, if you have to do one transaction per single insertion, well, for almost a little bit over 2.2 million users, it's over 2.2 million transactions. Therefore, it'd be infeasible moving forward to use like one single insertion. So what we did is we decided to do a batch inserter service where you're able to compute a new Merkle tree off-chain, and then just create a zero-knowledge proof that this Merkle tree was computed correctly, and then just submit this proof to the smart contract, and then register users in batches. Right. So we have we support 3 different sizes of batches. We support size 10, size 100, and size 1,000. These proofs are created using a zero-knowledge circuit that is in this repo, Worldcoin/semaphore-mtb, under prover and circuit.go. If anybody wants to check this out, I'm happy to give out these links for later, or talk about them more in depth after we go over the contracts. And once we submit this proof of insertion, well, this will now go into the World ID contracts. Let me just now open which contract I'm specifically talking about. So World ID has two routers or two proxies. One proxy is the top level proxy, which routes across different verification methods. So World ID is a permissionless protocol in the sense that anybody can create a new group, and by a group, it's a different method of verification, right? So there's this orb verification method, and in our protocol, it falls under group ID 1. We also allow for phone verification, which is a lower verification signal, but it's still useful for reservations, for example, for Worldcoin token reservations. And we have that one under the ID 0 within the protocol. And so you can think of it as just, not this one, this one. You can think of it as just a top-level contract that has a route for method, which essentially allows you to route to a given World ID implementation. And you can think of each implementation as just a separate Merkle tree, a separate group of users that are verified by some method, right? So in the case, if we want to verify that a person has been verified by an orb, that they have a valid public key that's been verified by an orb, well, we route for group ID 1, and this will return the contract at ID 1, which will be the main World ID identity manager. So here, there's a lot of things we can go through. Everything good so far in terms of the logical train of thoughts?
Yeah, absolutely. Keep on this train.
Okay.
Let's keep this thread going.
So the World ID, as I mentioned before, there's this proof that gets sent to the World ID contract. So let me just go back to this diagram to conceptualize where we're at. So the backend authenticates the semaphore public key. The sign-up sequencer batches sets of public keys. In this case, we do currently we do either 1,000 or whatever we have within the time span of an hour, whichever comes first. So if there's a batch of 1,000, we submit a batch of 1,000. And if 1 hour goes by and there's no proof that's been submitted, well, we create a batch for however pending identities there are. Then we create a zero-knowledge proof of insertion of the pending identities or semaphore public keys that have not been inserted yet. And we call the World ID Identity Manager the register identities method to insert the batch of users that are pending for registration. So now we're here in the register identities function. And the register identities function takes as call data, takes an insertion proof, which is a Groth16 zero-knowledge proof that we generate using Gnark, which is this proving system written in Go that uses Groth16. It's a library that uses 16 as a proving system, and it's underneath the semaphore MTB repo, right? So we use this proof. We also take in a public input as the previous Merkle tree root. Since a Merkle tree, it's a really like expensive structure in the sense that you're storing lots and lots of identity, and each identity commitment is a semaphore public key, which is 256 bits. So if you multiply 56 bits times the amount of users that we have, which currently is about 2.2, a little bit over that, then you can think that's really like too expensive to do operations on chain, right? Like if you have to do computations on top of 2.2 million items in a data structure for every single operation that you're doing on chain, well, you'd quickly run out of block space within a block. Like each Ethereum block has 30 million gas, and there's not enough gas to do those operations for Merkle trees on chain. So the way that you bypass is by these zero-knowledge proofs, right? Like you're doing the computation on top of the chain, and then you submit a proof of that computation on chain, and you can update the state results on chain for just the Merkle tree root. The only thing you need is the Merkle tree root as a public input to verify a proof, thankfully. So what we do is take the previous root and the root afterwards, and the index at which we're starting to insert new identities, alongside with the public keys that we're inserting. And from these public inputs, we're able verify the zero-knowledge proof. And once we verify the zero-knowledge proof, essentially what the zero-knowledge proof is doing is, okay, we had a previous Merkle tree root, and after we insert, let's say, 1,000 identity commitments or semaphore public keys, we have a resulting Merkle tree root, which is the post root. And after we verify the zero-knowledge proof, we verify that, okay, we went from the previous root to the post root, and we validate this computation happened correctly. And the latest of the smart contract is that is important is that you do need to insert every single identity commitment as call data to Ethereum so that you can reconstruct the any public data available on Ethereum. So our contracts, these contracts live on Ethereum to have the highest security assurances within Web3, pretty much, right? So anyone can just parse the World ID Identity Manager contract, which is deployed on chain. I can also pull up the deployment address in a little bit, and you can essentially just parse the identity commitments for each call for registered entities, and you'd be able to get all the current members Merkle tree or all the semaphore public keys, and you'd be able to reconstruct the Merkle tree off-chain just from public data. So this is like a way where we're centralization that anybody can verify that this Merkle tree is indeed the correct Merkle tree, and where we could probably like decentralize this registered entities method, where anybody would be able to, if they have a valid proof and if they have a valid Merkle tree, would allow for future decentralization, right? So if we have all this semaphore public keys on chain, so then we do some ZK logic where we're verifying that with the right values, and we're not essentially using something that the ZK system is not able to work. We're checking that the root, the previous root that we're as a public call data, as public call data is the latest that the contract had. Otherwise, we revert. We verify that the root afterwards also is something that the zero knowledge proving system is able to work with. This is just logic, so we don't end up with invalid inputs. And we also validate that each semaphore public key is also something that, in order like for someone to understand like what this validation is doing, is zero knowledge systems, they're able to work with really big numbers up to a really high prime number, and you are essentially just checking that the number you're with is within 0 and this really high prime number. Otherwise, this zero knowledge system is not able to work with that specific number. So we're just doing these checks to ensure that okay, this is fine. And then we just compute a hash. This is just to ensure that the state transition is happening correctly. We compute a hash of the index at which we're starting to insert, the previous root, the root afterwards, and the set of public keys we're inserting. And this is sort of the hash that we're checking off-chain in the circuit. I'm going to skip a little bit of the ZK logic, otherwise I'd be here for a few hours. So just to like summarize, this is just a way that the ZK circuit has to be able to check that the computations happen correctly on-chain. We also have a sort of set of verifiers in the contract. So in order to verify a zero-knowledge proof, this concept of a verifier. A verifier is a contract, a normal Solidity contract, and each verifier needs to be specific to the circuit that you're proving. So we have 3 different circuits for insertion according to the different batch sizes. Right? We have a batch size of 10, batch size of 100, and batch size of 1,000. And so if we're inserting, let's say, a group of 1,000 identity commitments or semaphore public keys, then we get a verifier from a mapping which corresponds to this like variable of 1,000. So this is done on each registered entity's call, right? So if we're inserting, we get the verifier for verifying the circuit of a batch of 1,000. We verify the using the circuit's verifier, right? We do like insertion verifier proof, and we pass the proof that we got as call data, which is just it's 8 coordinates of elliptic point groups. I'm happy to go into more detail if that's interesting, maybe in probably a different video. It would be too long for this one.
We need to introduce a ZK Wednesday and maybe a Rust Thursday.
Yeah.
Well, as a follow-up.
Exactly. So once we verify this zero-knowledge proof, we update the root to the new root, like the latest root of the contract to the one that we computed from the zero-knowledge proof off-chain computation. Otherwise, if the proof is not valid, like the verifier says hey, the proof is incorrect, then it reverts with a validation failure. And it's the previous root, that was the canonical root, into the root history. This is useful so that if a user is doing a verification, in this case, like if they're proving that they're in the set of registered users, well, if they're proving against an older root, it would would be invalidated. So what we introduced is this concept of we have a root duration. So each root is valid for about a week. And if a root expires, you can still create proofs against an older root if it's still valid in history. So after we compute all of that, we have this send root to state bridge method, which essentially propagates the latest root to other chains. Currently, we're supporting Optimism on Polygon POS in production. And what this does is that it essentially, there's a World ID state bridge repo, which let me think if I can still find the older one. Yeah, this one, which is current production. So there's a state bridge contract, which essentially bridges the state to Optimism and Polygon. There's a send root multi-chain method over here, and it's Optimism and to Polygon alongside with its timestamp. And the contracts on Optimism and Polygon receive this root. They receive this root via the receive root method, and users can now and verify them on Polygon and Optimism using the proof method. So a cool thing to note is that the set of Worldcoin products, there's the World app. The World app is a mobile app. I can probably show it. World app. It looks something like this. If I can find the mockup, it looks something like this. So this is essentially a front end, like a client, mobile client, both in iOS and Android, for a smart contract wallet, which uses the Gnosis Safe multisig. And these wallets live on Optimism, right? So when we are doing the Worldcoin token airdrop, we are verifying a proof that a user is unique and that they've not claimed the airdrop before. This is a weekly recurrent grant or airdrop, if you will, weekly recurrent grant. It's a better word for it. And once they verify the fact that they're unique and they've not claimed the grant this specific week, well, then the token gets sent to their specific wallet address on Optimism. And since you're proving these things on Optimism, well, you need to have an up-to-date root of the World ID Merkle tree on chain. And so this is why we're bridging state over to Optimism and Polygon in the first place, so that users can claim these tokens over on Optimism. And yeah, so that's what the state bridge does essentially. Any questions so far? I know I'm just talking, but I don't know how if people I'm saying or if I'm clear.
Yeah, this is incredible so far. Thank you. It's a really extensive set of repos because you obviously have multiple different products and really complex logic. I would love to know what informed your design decision to locate those Gnosis Safe contract wallets on Optimism. Is there any specific reason you're using an optimistic oracle? Excuse me, an optimistic L2?
The reason why we chose Optimism when we first were thinking about things is mostly their open source nature and their like fully community proactive sort of point of operations, essentially. Like if you compare like all the different roles, each of them are at different levels of maturity. I recommend people go to DcBuilder.com to really be able to measure how much or which stage a rollup is. Sorry, my internet is slow. Apparently with the live stream and such. But yeah, if you go to l2b.com, you can see, okay, this is an optimistic rollup, this is a ZK rollup, and little pie diagrams, which sort of tell you things that have shortcomings in, like technical shortcomings, or like still like how wise they are and how permissionless and how many like different things they have. So the reason why we choose Optimism is, for one, it's fully open source and free to use. They're not, and they have this good modular design that allows interoperability across different OP stack chains and within the deployment of different OP stack chains. And so for now, we to just go with an ecosystem that, of course, has cheap fees for one. So rollups meet all rollups meet that criterion. It's essentially something that has this sort of modularity aspect. So in the future, if we decide to launch our own rollup, we'd be able to using their stack So currently we're not on our own OP stack. It's something that we've been thinking about. But yeah, that's like sort of one of the reasons why we chose Optimism over other ones. I do have a talk coming up at L2 Day, actually this event that's right here at L2 Day in Warsaw, which will be a little bit more about how Worldcoin is thinking about scalability, which will be recorded. So I definitely suggest people, once that's up to watch that if they want to know more. So yeah, the wallets are in Optimism so that you have essentially cheap fees for users. And another thing that we do, that we subsidize each of our users' transaction fees via transactions. Right? User, when they're doing a transaction, they see a transaction as free. They send money or claim tokens, and all of those transactions are free because they're by us. And the reason why we can subsidize it is because it's on an L2, and it creates like a better user onboarding flow. And the way we actually double resistance from those subsidies is by having people having a verified world ID. So if they have a verified ID, we're able to subsidize them. This prevents DDoS, right? So that people cannot send like million transactions per user for free. Yeah.
Right. So you have like the perfect confluence of a proof of personhood and uniqueness protocol and ensuring that users get free transactions, because scalability is obviously one of your key values here.
Yeah. I want to essentially onboard as many people as to self-sovereign finance and self-sovereign identity. And self-sovereign finance and identity essentially is something that people can use without intermediaries, right? So using blockchains and without compromising their privacy, using proofs, and something that is also cheap and affordable for users that are not with traditional blockchain applications. So it's like a good on-ramping, onboarding experience, from the sense that the wallet is really user-friendly. It abstracts a lot of the complex blockchains away, and it makes things really simple for users to do.
Amazing. And one of the other core values that seems to be a part of your design approach, from what I'm seeing here, is balancing the transparency of blockchain alongside privacy. Like you mentioned earlier, that you can reconstruct the whole Merkle tree of identities, but obviously all of those identities remain totally pseudonymous.
Yeah, exactly.
And are there any other ways in which you are trying to balance transparency and privacy in the core designs?
I'm not necessarily sure to answer that specific question, if there's any other ways in which we're trying to do that. I mean, there's a lot of different moving parts and a lot of different like security surface areas where you can ensure privacy, from hardware to its firmware, to the backend, to the client, to the blockchain contracts, to the ZK system. There's a lot of things that have audit surface area. So we've done audits, public audits from Nethermind for the contracts, from least authority for the cryptography that's used. There's also several other audits we're going to be talking more about as they finish. And yeah, like there's different things that you can ensure privacy and have third parties validate that, okay, we're actually doing what we're saying we're doing. And for the things that you can publicly verify on blockchains, well, those are simple to verify, right? Simpler, at least. We recently, for example, had Bartek from L2Beat verify our trusted setup ceremony, which is just like this thing that you do to make proof systems, or like ZK proof systems secure, meaning that the prover cannot lie to a verifier, and that we're not just making up these ZK proofs and just to like pretend that we're doing ZK when in fact we're not doing ZK. So Bartek verified our circuits for insertion, like these registered identity circuits. And he's currently also verifying that we're actually using semaphore with the right parameters that semaphore specifies in their documentation for the verifier. And yeah, like there's different ways that you can ensure privacy across the stack and ensure transparency. And as these mature more and more, there's other technologies that we're planning to insert to actually like get better in terms of the guarantees that we're providing for our users in terms of privacy and scalability and all of these sorts of things. The white paper really goes a lot more in depth at some of these challenges from the technical point of view, as well as from the social point of view, because part of the security risk is not necessarily technical. It's just literally like social, where users are able to expose their private keys to people and things like that. Like it's just like crypto user experience in general. It's a thing that we've been struggling a lot. And things like smart contract wallets and account abstraction and different features that are built on top of that solve those. I think like it's a problem that everybody in the crypto space is facing currently.
Absolutely, yeah. I think the next generation of Web3 and crypto products will have to innovate on UX, and we're seeing that with your products, with things like Magic Wallet and so on, using social recovery and or for credentials.
Yeah, 100%.
Great. Let's go through the next little stint of the contracts.
If I may ask just quick, what about if a wallet gets compromised? Like, what are the procedures if
a wallet gets compromised? So currently we don't allow the so it's a self-custodial wallet in the sense that a user can the user has its private keys stored on its phone, but we do not expose the export method or function within the app. This reason is mostly because like most of the users that are using our app are beginners and they do not have a proper concept of what a private key is. And so they're really prone to social engineering in this sense, that if somebody tells them, hey, show me this thing, if you click in here, and people would be prone essentially to lose their private keys. So what we allow is like it's a self-custodial wallet in the sense that the private key is only on the phone, and the user can always spend the balances that are on their wallet, and they can always withdraw to any other like self-custodial wallets where they can export their private keys, like like the usual MetaMask, Rainbow, etc. In terms of the key for the world ID, which is separate, there's two private public key pairs. One is for which is a traditional like Ethereum EOA like private key pair, which is a signer on this multisig, which is the Gnosis. Well, like now it is called just Safe wallet. It's a signer, one of one signer on a wallet. So this EOA signs a transaction on a wallet, blah blah blah. And then there's the other private public pair, which is the semaphore public private key pair. Currently, we're not allowing export of that private public key pair at all as well. For the reasons that if people would be able to trace those private keys, they would be able to essentially bypass the SIB resistance guarantees, right? If you're able to export that private key, anyone would be able to sell that private key, and people would be able to do more attestations of uniqueness. The way that we're targeting that sort of kind of worms is by allowing a recovery flow in which if a user goes to an orb again, they would be able to invalidate their previous public key and generate a new private public key pair. So if there's a seller, right, if you sell a private key pair, however, like if you're able to extract it from the phone, for example, able to sell that private key pair, well, the seller has no incentive of buying, the buyer has no incentive for buying it, because the user can always just go to an orb again and regenerate a new valid one and invalidate the one that buyer is buying. So that's sort of like different ways of ensuring that the personhood is tied to one user and is not tradable, and you are actually enforcing SIB resistance at the social level, the incentive level, and the technical level. Actually, that flow is something I'm working on currently, this recovery flow. It's going to be rolled out over the next couple months.
Okay, very cool. Thank you.
Yeah. Yeah, I can go now over the verification flow, which is like the semaphore flow, if you want.
That would be perfect. Thank you.
Okay. So the verification is like this concept that I explained before, is when a user wants to prove that they're a unique user, like they're a unique leaf, their public key is a unique leaf of the Merkle tree. What they do within the app is they create, let me see if I can actually find it over here. So for example, sign in with Worldcoin. I'm wondering if there's just, I've not seen this documentation in a little bit. Just find it really quickly. If there's just a snapshot of how it looks within the app over here. Okay, let me find it maybe over here. Yes, so the user, when they download the app, they have this little button which is essentially meant to QR code. And when they have that QR code scanner turned on, well, they're able to QR code that's essentially generated by the World ID SDK, which is this thing. The SDK is just a library that allows developers to build apps with World ID, like front ends, and allows essentially apps to integrate with World ID to create zero-knowledge proofs of insertion. It's zero-knowledge proofs of inclusion. That's done using this ID kit library, where the ID kit library generates a QR code for a user, which is associated with an app and an action ID, right? So you as a developer, you create an action. So let's say vote within my DeFi protocol governance module, for example. And there's one action per user, and the ID kit SDK just keeps track of each action ID, right? For the vote one ID, for an app ID like this. And the SDK generates a QR code that the app can scan, and the user then generates zero-knowledge proof pertaining to that specific action, right? So they first create a zero-knowledge proof that you're part of the set of registered users, and that you've not done this vote one action before as a given user. And then once you generate the zero-knowledge proof, the ID kit SDK essentially sends it to the chain, verifies, and listens. If the smart contract verifies this proof, then you get a result, and you do the on-chain action. In this case, you change the vote for this person on-chain to, right, like for this address that it's voting. Like they voted for a person, whatever, for this proposal, yes or no. Let's say like Uniswap is updating the contract, so you can like vote for yes. So this is sort of like the verification and how ID under the kit works through the documentation. If you want to integrate it as a developer, you want to build apps with World ID to make sure that your users are, for one, unique, and for two, that your app cannot be Sybil attacked, in which users can do more than that when they're supposed to not be able to. And so how this ties into the smart contracts is in the diagram, right? So I have this ID kit JavaScript library, or Semaphore RS, which is a Rust library that has banned Semaphore, this proof, and the smart contract that integrates World ID. So for example, I'm going to demonstrate how a smart contract integration of World ID looks like. So we have example airdrop, which is a sort of set of repos we have to show sort of like how a demo integration of World ID looks like. So you have an airdrop contract that essentially you deposit some tokens to, and you can create a grant. And once you generate, once the deployer of this contract creates a grant that people can claim, well, there's this claim function that has a receiver, a root of the Merkle tree against which you're verifying, a nullifier hash, sends a hash of an action and an app ID. Video quality is really, maybe that's my internet connection I see from YouTube. Maybe
Let me try it. Make it bigger. No.
Is it readable?
Yeah. I think it just takes like a second to load properly, and then it's fine.
Oh, okay.
Hopefully.
Yeah,
I'll
just to render.
I'll try to not do a lot of movement. Yeah, unfortunately, unless I usually have my proper setup with proper internet, I'm traveling at the moment. There's this claim function that has a receiver. The user, when they want to claim a airdrop, they can claim it privately by first like saying, okay, I'm a unique person and I've not claimed this airdrop before, but I can select whatever address it is, even an empty address, and I can fund it later however I want. So this is like a cool part of ZK. If you're able to uniqueness, you can receive the airdrop whatever you want. And then you pass the proof and the nullifier hash. So first you check that the nullifier hash has not been consumed or done before. This just means like, okay, the action has not been done before, because each user can only generate one valid nullifier hash for a specific action for a specific app ID. They're not able to do more than one. So if the nullifier hash is unique, meaning that it's not been done before, this is just a mapping of nullifiers Boolean. Right, I go here, it's a nullifier to a Boolean, right? So if a nullifier has been done, the Boolean gets set to 1, right? It just means that it's been done. This prevents double signaling, as is in the NAT spec. And once you verify that this has not been done before, well, then you verify the zero knowledge proof that you're actually a unique user and that you've not done the action before, right? So then you verify the proof, you set the nullifier hash for that specific hash to true, right? So you've already done that action, and you transfer the token from the contract to the receiver. And according to the airdrop amount, this is just the token amount. Like a sample integration of if you want to integrate World ID, how it would work. You would have this, you would import the World ID router, and then you would route for this specific group ID that you want. In this case, the orb would be group ID set to 1. All of these you can set in the constructor of the contract that has the World ID integration. The root of the Merkle tree, this is passed from the ID kit SDK. And same with the receiver and the nullifier hash, the action ID and the proof. This is all passed from the SDK. This is not something that users are expected to worry about. Or like developers integrating with it are expected to handcraft themselves. We have a library for doing these things. So this is like a sample sort of an integration. So this verify proof method is what lives on the World ID contracts. And this is a semaphore under the hood. So if we go to the, right, we have a router. There's ID 0 for the phone, group ID 1 for the orb on different networks, Ethereum, Optimism, or Polygon. And we have on the router, we have the verify proof method, which then routes to the specific identity manager. So in this case, 1 for the orb. And the World ID identity manager has a verify proof method that is over here. This is on the state bridge. Let me find the one over here. Verify proof. And the bottom one over here. There's a verify proof method on the identity manager. And this essentially calls the semaphore verifier contract with the verify proof method. So this is a contract done by semaphore. And this, what it does, it's proving that your specific semaphore public key is in the Merkle tree, and that this nullifier hash has not been done before. You verify all of these things, and if this contract doesn't revert, which it will revert if the proof is invalid, then your app can progress with the other logic that it has, right? So in the demo integration that I have over here, if this doesn't revert, if this verified proof doesn't revert, well, the user can claim a token. In this example airdrop contract integrating World ID. So that would be sort of like the speedran version of what the register identities flow and the verification flow, which are the two main flows of the contracts. There's a bunch of other logic that is mostly like relating to the ZK stuff, like setting up the contract so that everything works. But yeah, that's like the high level flow for verification and registering of users.
Awesome. So you mentioned voting and airdrops. Perhaps you could describe to us maybe one or two other really interesting use cases that you've thought about or you've heard from other devs of building on top of World ID.
Yeah, for sure. So one would be, for example, quadratic funding. So quadratic funding is this concept in which you can distribute grants or essentially donations proportionally to the amount of people that want that donation to be given to a specific party. So, like traditional grants have worked that people just send some funds directly to a person they want to support. But if you have this concept of matching rounds, which was introduced by Gitcoin, is that you have some funds you can donate yourself. And based on the funds that people donate to a given project, other bigger parties that do not necessarily know where to allocate these funds, they just distribute the funds according to this mechanism called quadratic voting or quadratic funding. There is a good website called WTFsQF.com. Is it that right? QF.com? I think so. Yeah. So this explains sort of like the concept of quadratic funding. And this is something that's uniquely enabled by proof of personhood, right? So if you have proof of personhood, then you're able to essentially have these votes from users to be counted as unique votes. And then you can match proportionally to the amount of people that have been like giving contributions to. So currently Gitcoin itself uses their own Gitcoin passport sort of tool that aggregates different proof of personhood or Sybil resistant tools, right? Like you can log in with Facebook, with GitHub, with your Bright ID, with your proof of humanity, which is a different project, like et cetera, et cetera. Like there's the different integrations that they have. And if you have all of these, then your score for matching is really high. So if you did a World ID integration, for example, then if the user proves that they have a World ID, well, they can have a really high matching because their Sybil resistant guarantees is pretty high, sorry. So this is one use case. Another use case, for example, would be social attestations. So in this world where we want to sort of be able to make meaningful statements about things, for example, we want to say, I don't know, the simplest example I can say is like Google Maps ratings or Yelp ratings, right? Like you have a restaurant, you want to vote that this restaurant is good. In a digital environment, there's no way to claim that these 5 things on Google Maps are valid because there's an unlimited upper limit to the amount of Google accounts that I can make. And therefore, I can vote with all the Google accounts for like my restaurant I just made up, and I can give myself a million 5-star ratings, right? There's no way to Sybil protect these apps. So a good way for proof of personhood here is if you want to do a rating or an attestation in this case that this is good, then you can gatekeep that by proof of personhood. A very trivial one that is really similar to this is social applications, right? Like if I have a Twitter and I want to make sure that there's no bots, and I'm like, I don't know if you've used Twitter recently, but it's getting worse and worse in the sense that there's lots and lots of bots under every single post, lots of scams, lots of all these sorts of things. So if you want to, for example, limit the amount of bots, you can integrate various Sybil resistance protocols or apps that sort of try to guarantee Sybil resistance, and make users just verify with those. And if they're verified with those Sybil resistance protocols, then you can allow them to create one profile, right? So if you can so have higher chances that the profile that the person has is unique, that they're not creating thousands of bots. So that's sort of like a few other use cases. In general, like any app that you want to build, where you want to make sure that an action is done by a unique human, or that the action is not done more than once per human, for example, it's something where something like proof of personhood or World ID would be useful for.
That's very cool. Yeah, thanks for those.
I think what I really love about Worldcoin and what you're building, DC, is that you're humanizing smart contracts. I know we chat a lot about hypotheticals and use cases in blockchain, but a lot of what we do in Solidity, especially in the Solidity community, is very far out along the curve of experimental finance. And getting back to the basics of what really makes an impact on people's lives is really incredible. So I really appreciate what you guys are up to. I'm conscious that we're coming up against time now. I'm not sure if you have any closing remarks or anything you want to let the listeners know.
Yeah. If more about the technicals, like just feel free to ping me on Twitter, on twitter.com/DcBuild3R, or on Telegram, or sorry, x.com/DcBuild3R. I forgot.
Good save. Good save.
Or Telegram. If you have questions about Worldcoin and like the technicals of it, in the white paper, so whitepaper.worldcoin.org, there's different sections that even like go over why we chose biometrics for proof of personhood, why we had to build our own hardware, why we chose everything that we chose, different things about how we think about decentralization, et cetera, et cetera. There's a lot of things that take a lot of time to get into, and it's too short for this video. Other things I want to mention is, like you mentioned, right? Like we're trying to build that would allow a better user experience on top of distributed systems, like in the sense that I don't know if you've read Vitalik's article, 3 missing building blocks or something like that. I forgot the name. It's the one that talks about just like the scalability, privacy, and user experience improving. And I feel like proof of personhood is something that is core for pretty much all those 3 to actually be built at scale. Because otherwise you're just able to DDoS these networks, right? Like if a resource is virtually free, right, and everybody can do it, and then they'll do it, they'll spam the network. The network will essentially, if you ever make something free or cheap, then there's no limit on the amount of transactions that people can do. And again, like if a resource becomes again, it will become expensive. So something like proof precedent can only allow unique people do actions, which creates better user experience across different protocol large.
Right. It seems that Sybil resistance is really the key to the next generation of self-sovereign identity.
It's one of the building blocks. Definitely one of the building blocks.
Amazing. Before we end off, speaking of Twitter bots, is it true that if I send you Ethereum, you'll send me back double?
I wish I could.
DC, thank you so much for joining us. We really appreciate your time. We know you're busy. Perhaps we can schedule a follow-up sometime in the future. I know there's so much substance we didn't get the time to cover. Maybe we can even do a ZK specific session sometime, or venture out of our comfort zone and chat about Rust or Go.
Sure. Sounds good. Sounds good. Would happy to.
Definitely.
Amazing.
So much. Yeah.
We really appreciate you and what you guys are doing. And thanks to all the listeners for tuning in.
Yeah,
Thank you.
It's been a good one. So another episode brought to you by Linum Labs and Web3 Sanctuary. Catch you guys next week.